Hello everybody, welcome back to From Rhythm to Algorithm Part 42, Numeric Iteration. Ended with the last episode, we conjectured that there were 6 colors, talked about base and range and a bunch of different contexts. But I have some good analysis for today. Again, not the final iteration function or final result, but a lot of just empirical evidence and just structured discussion of number theory terms and relationships and what I see as contradictions. So again, we were trying to form a formalized, definitive, physical, geometric proof of how many colors are there. We can definitively look at shade and say there are 3 clear iterations. We've said it's a base 2 number system. We've talked about the universal evolution being uniquely one way. So maybe 2 is a complete set or complete physically. So we're just going to really explore the relationship between 2, 3, 6, and 7, right? Why was 6 afraid of 7? Is 7, 8, 9? That's some sort of result already, but let's start with some definitions. Cardinality versus ordinality. Again, even picking up once from the once, twice, thrice episode, just revisit some of that stuff with our new analysis tools. Cardinality is the size or magnitude of a set. Ordinality is the rank or priority. And then I have of a set in brackets, specifically because that reads completely logically to me. Ordinality is the priority, or ordinality is the rank, right? The military, you have rank, you have priority. But the distinct mathematical difference between cardinal numbers and ordinal numbers is ordinality orders. Fundamental relationship of iteration of mathematics and numerals with physics. Cardinality is your absolute value, your total amount. Ordinality describes the relationship of elements of a set. So, and again, I just have, as a result of infinite biological uniqueness, taking that axiom to words. All words have unique definitions that are relationships derived from contexts that are uses. Just for clarity. But now here's, right, I want you to, I don't have the episode or the commercial right here, but 3, 4, 5, 10 years ago, there was an Old Spice commercial where they go, you know, they swipe an armpit and it says fresh, and then they swipe another one and it says fresher, and it says freshest, then it says freshershest, right? So you have a base, you have something, you iterate it, you make it better, and then you iterate it to make it best. So there's 3, like base, better, best. Those linguistic terms are descriptions of iteration, of improvement. There's 3 of those. Right? We have mean, median, and mode. Mean being average, median being middle, and mode being most. I don't know if that's something I just don't even know where that word came from there. But median, medium. I don't know what the relationship is there, but median's the middle, but mode, right? Mode happens the most, best. So again, this is some linguistic result of, you know, maybe base 3 system, maybe 3 is unstable, there are only open systems. But then how does that result resolve with the 2 to the n instinct, right? 2, 4, 16, 32. Everyone does that. So what's going on here, right? Maybe better and best. There's 2n improvements or 2n iterations because you have to start with something. You have to have a base, the base of vibration, the base of a marker, the base of whatever. But let's just, now how about cardinal versus ordinal numbers, reading them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. The only ordinal number with 2 syllables is 7. 7 is not even, but it almost is. It's literally even with the letter S in front. Some sort of geometric iteration with the words and the letters, something. But for the ordinal numbers, right, now we have 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. Every number past 9 is an iteration of these numbers. But we clearly see linguistically the sound That's modification of syllability as a result of 3 unique words for the only 3 ordinal numbers. And there's only 3 prime numbers. So, big science, big math fact right there. So we have 3 primes, and then the sound E, right? We've talked about the letter E representing, or the letter Y representing the sound E at the end of the word, indicating generality. Well, any number 20, 30, 40, 50. So again, some iteration, clearly a result of the analysis I've provided. Right, we have 3 ordinal numbers. Order indicates order, 3 primes as the base. Then we iterate that base. A range is an iteration of a basis. Basis iterates to range. And now physically, because of physical size, right, 7 uses of a vocab word. I think people think about sex about every 7 seconds. So 7 might be the iteration limit of relative size. That's what I'm thinking today. But, right, then we have order and music modes, right? Ordinality describes order. The different music modes are iterations, are ordinals, require ordinality. So how does that relation of 7 things with 7 relate to the conjecture of 6 colors? Well, simply 2 multiplied by 3, that's 6. 3 multiplied by 2 is an equivalent mathematical statement, which is 2 iterations to 6. So maybe 3 iterates twice. 3 is our base, iterates twice, better and best. 7 is our iteration limit. I don't know. We're fucking really close. Please pay me. Thanks for watching episode 42. And now, actually I want to end with this, right? From rhythm to algorithm. An algorithm is a function or is related to ordinality, a set procedure to do something. Rhythm is not rhythm is also ordinal, but algorithm is certainly ordinal. What do you do first? What do you do second? What do you do third? So that's what I have for episode 42, numeric iteration. Pay me my fucking money. Thanks for watching.